Okay, so now I want to do a side-by-side comparison of definite integrals and indefinite integrals. So let's begin with definite integrals and sort of analyze them. Definite integrals. So definite integrals are evaluated from one place to another place. So for example, we could have the integral from a to b of f of x dx. And so a definite integral, first thing that you notice is that it has limits of integration. Limits of integration. And what it outputs, it outputs a number. Outputs a number. And the reason it outputs a number is because it represents the area under the curve from a to b. The way to calculate the definite integral is to calculate using the antiderivative, okay? So that's a definite integral. Now, let's look at an indefinite integral. Indefinite integrals are more general, and they're called indefinite because the first thing that we see is that indefinite integrals do not have limits of integration. They're not measured from one place to another. So it's just written as the integral symbol f of x dx. So the first thing we'll say here, the first bullet point is there are no limits of integration. No limits of integration, okay? And what this guy outputs, what an indefinite integral outputs, is a function. It outputs the general antiderivative of this function. Outputs and I'm going to be a little bit more precise here. It doesn't output one function, it outputs an entire family of functions, which is interesting. And so, what do I mean by that? What are these functions? Well, the functions are general, it outputs a general antiderivative, which there are more than one. So you get all of them outputted from this function, and because it's a family of functions because of the plus c, right? It doesn't matter what constant you tack on, it will be an antiderivative of this function. So there are a bunch of functions that are outputted by this. And what is the output? So this guy, this indefinite integral, also uses the antiderivative like the definite integral. It's just after you get the antiderivative with the definite integral, you have to evaluate it at the limits of integration and subtract, okay? So there are definitely similarities and differences here. I wanted to point those out. Now, I want to do an example of one of each of these integrals next to each other. And then we'll do some discussion there too. So let's consider the integral from 1 to 4 of the square root of x minus x all over x squared with respect to x. This is a definite integral for sure. And so, in fact, let's do the indefinite integral. Sorry, let's do the indefinite integral first. So the indefinite integral, we're looking for this to output a family of functions. We want the most general antiderivative of this guy. And at this point, in the process of making my videos, we know some basic ways to integrate. So the most basic way to integrate this is to rewrite the function first by dividing each of the terms on top by x squared. Okay, so this is x to the 1/2 divided by x to the second. You'd subtract the exponents and get x to the -3/2 minus x to the first over x to the second is x to the negative first. And now we just get a difference of power functions. Okay? And so we're looking for the antiderivative. So raising the power by 1, I get x to the negative 1/2. Multiplying the coefficient by the reciprocal gives me negative 2. Minus the antiderivative of x to the negative first is the natural log of the absolute value of x, and plus c. So that is the general antiderivative of this function, and that's an indefinite integral. Now let's look at a corresponding definite integral, the one I wrote initially by mistake. Let's evaluate the same function, the same integral, but from 1 to 4. And I'm going to work this problem out as if I hadn't already done the indefinite integral. Okay? So, same process, except every step here you need to write your limits of integration. As soon as you don't write those, there's no way that the two would be equal, because one represents an area while the other represents an antiderivative. So notation here is rather important. Sorry, now we're going to divide. So again, we get x to the negative 3/2 minus x to the negative 1. Make sure to use parentheses here because of this minus. We're trying to apply the integral to this entire function with respect to x. Do the antiderivative. And now the difference comes in. We're not, minus the natural log of the absolute value of x. This is where you get some differences. In a definite integral, you don't put a plus c. You put brackets around it, and you still need to evaluate this particular antiderivative from 1 to 4, and you go further. So you plug 4 into this, which gives you negative 2 times 4 to the negative 1/2. So that's 1 over the square root of 4. So that's 1/2 times negative 2, that's negative 1. You can check that out on your own. Minus the natural log of the absolute value of 4. The absolute value of 4 is just 4. So I need to take all of that minus what I get when I plug in 1. So 1 to the negative 1/2 is 1, so I get negative 2, minus the natural log of 1 is 0. And so when I simplify all of this down, I get negative 1 plus 2, which is positive 1, minus the natural log of 4. And so you can see that the output of this definite integral gives me this number. And this number represents the area under this curve from 1 to 4. Okay? Over here, the indefinite integral outputted just the most general antiderivative. And so in this case, you need your plus c. Over here, you could put your plus c in your definite integral, but when you evaluate and subtract the c's, you're going to cancel anyway. So we typically do not put them here. Now, I want to kind of show you a hybrid approach to doing a definite integral. Some people like to do this because they hate writing the 1 to 4 on every step. Okay? Now, it's really not that much different. It's really about notation and how to think about this. So let's say we were given this integral, definite integral from 1 to 4 of the square root of x minus x over x squared dx. And you could use the indefinite integral to help you here. So you might start by looking at the indefinite integral first. So the indefinite integral would be the integral from nowhere to nowhere, right? It's just any limits apply. And you get x to the negative 3/2 minus x to the negative 1 dx. And so you get negative 2 x to the negative 1/2 minus the natural log of the absolute value of x plus c. There's your indefinite integral. And then what you could do is you could resume with your definite integral here by just saying, okay, now that I know that, I could say that this guy equals, well, I just need this part, negative 2 x to the negative 1/2 minus the natural log of the absolute value of x from 1 to 4. And then you could finish here with all the work we already discussed. And so You may find that as you practice, you like this idea because you're never rewriting your definite integral with your limits of integration. All of your integration work can be done in the context of your indefinite integral, and then you can apply this antiderivative, this particular antiderivative, without the plus c to the definite integral, and then evaluate from there to finish. So you can certainly take any approach you want as far as definite integrals go there, but it's certainly worth mentioning this concept because in my classes I always get the question about writing your limits of integration. If you want to avoid that, take this approach where you work on the indefinite integral first and then apply it to the definite integral later.